Next topic, critical region. In a statistical hypothesis test, the critical region is a set of value for the test statistics. So it is a number, right, in a test statistics in which the null hypothesis is rejected. So that is the region. In that region, the null hypothesis is rejected. If you assume some hypothesis, we know statement, it is a statement regarding the statistical test, whatever it is, right? Then you have to calculate the value of the given data, right? So they have given sample size, population size, then mean, whatever it is, proportion. So anyway, we are having a formula for that test statistics. So using that formula, we are going to find the value of that particular statistical test. Suppose if that value is inside that critical region, then your assumption, that is our assumption of null hypothesis, is just rejected. We cannot. So we have to accept the alternate hypothesis. So that region is called critical region. So this is also called region of rejection, that is rejection region. If the calculated test statistics from the sample data falls within the critical region, then the assumed null hypothesis is rejected. So we'll see, suppose critical region or region of rejection. So these two, right, both sides in blue color. Non-critical region, non-rejections region, that is in the center, that is the in pink color, right? So reject the null hypothesis H0 in that particular region. If the value of the test statistics within this region, then you have to reject, right? So reject null hypothesis. Anyway, this is negative side, that is the positive side. Center, middle is the origin, z is equal to 0, right? So in the non-critical region, you have to accept the null hypothesis, right? You have to reject the alternative hypothesis, right? Next, confidence interval. A confidence interval is a range of value, that is an interval between 0 to 1, 2 to 3, 2.5 to 7.8, minus 4 to 7.2, right? These are all the interval, open interval, like, alright. In that particular interval, if your test value is inside or your parameters is inside, definitely you can accept that parameter. That is the confidence to accept the parameters, right? Population parameter, that is from the sample parameter we are going to calculate the population parameter. So whether we can confidently accept that parameters, for that we are finding the confidence interval. If it is inside the particular range, that is that interval, then you can accept. So how much confidence we are having? 95%, 99% we can accept, right? Definitely, right? That is what we are having confidence interval. So calculated from the is confidence interval calculated from the sample data, which contains the true value of unknown population parameters like mean, proportion, etc., right? Example, if the 95% confidence interval for the average marks in statistics tests of all students in class is 87 to 97, then that implies we are 95% confidence that the true average marks of all students lies between 87 to 97. That is what. So this is the confidence interval between the negative to positive, or within positive or within negative, whatever it is, there is an interval, right? For example, I am giving 95% confidence interval, right, which is marked in the red. So 2.5%, that is also 2%, because we know in the normal curve total value is 1, area value, right? Total area is 1. So if z is equal to 0 is the middle, then left side 0.5 and right side area 0.5. So negative side you are having 0.5 area and positive side you are having 0.5 area. So rejection region, so remaining you are having, so 95% completely we are having confidence interval. So balance 5%, so dividing each, right, 2.5% that side and 2.5% this side, that is the rejection region. So confidence interval 90%. So this rejection region, balance you are having 10%, so left side 5% and right side 5%, right. Next, critical value. Critical value are defined as the specific point on a scale used in statistics test. These points help determine whether the result of the test statistical is significant or whether the test value is significant or not. So if you want to check, we are using the critical value. The critical value defines the upper and lower bounds of the confidence interval. So lower limit, upper limit. So from the lower limit, that is the point exactly, that is the significant value. Similarly, upper end. Suppose if you are having confidence interval, so for example in the previous case 87 to 97, 87 lower bound, 97 upper bound, right. That is called the critical value, right. After below the critical value, rejection. Above the critical value, rejection region, right. Critical value is the value is compared to a test statistics in the hypothesis testing to conclude whether the null hypothesis is to be rejected or not. If the value of the test statistics is less than the critical value, hypothesis accepted, right. Critical value, so normally if it is, suppose upper end we are talking about, if it is less than 97 you have to accept, right. If it is greater than the that lower end, then the value is rejected. So that is called, right. If it is a negative value, suppose so negative value is -1, suppose for example, if it is more than that, right. So -1 to +2 for example, if it is more than +2, so you have to reject, right. Similarly this side also, if it is more than or less than, right, less than the negative value, right, you have to reject. So simply if we are having the calculated value and we are having a tabulated value, the all critical value values are based on the that confidence interval, 5%, 1%, 2%, 10%. So there is a standard table is there, we have to compare that well. If calculated value is less than the tabulated value, you have to accept the null hypothesis. If the calculated value is greater than the tabulated value, the null hypothesis is rejected. So that is what, if that value is called the critical value, right. If the value of the test statistics is less than the critical value, then the null hypothesis is accepted. If the test statistics is more than the critical value, the null hypothesis is rejected. The critical value divides the distribution graph into the acceptance and rejection region, right. So these two value, so this is the critical value, the line marked in the black, non-rejection region, rejection region, right. So these two are critical value, that is what I told you. So in the rejection region, you reject H0, right, on the both side rejection region. So in the central region, non-rejection region, you accept H0. Level of significance. The level of significance is the measure that measures the strength of evidence, right. So how much the samples are conclude our hypothesis, right. Accepting, whenever you are accepting hypothesis, how much the significance level. So that is what the level is. The level of significance is a measure that measures the strength of evidence, right, that must be present in the sample data, right. It defines whether assumed null hypothesis is to be accepted or rejected, right, based on the level of significance, that is the evidence. So we have to reject or accept the our assumed null hypothesis, right? It is denoted by alpha. So common level of significance in the all problems we are using 5%, that is 0.05, or 1%, 0.01. In rare case we are using 0.10, that is 10% level. The level of significance is the probability of rejection, right, when it is actually true. So in a medical research, for example, researchers test new drugs or treatment. They need to be very sure a treatment or new drug is effective before approving it for general public use, right? Normally they will test. They will fix a common significant level, 5% or 1%. So before concluding test, before starting this test, they fix the significant levels. 95% we are having confidence, then okay, or 99, sometimes it is very that is so critical cases, so 99% they need a confidence. In that case they use 1% level, right? This means there is 5% or 1% chance of researchers could conclude, right, that the new drug or treatment is effective when it is not, right? So that means they are taking negative. So new drug is not effective, or the treatment is not effective. Not effective means that is 1%. If you are taking 99, 1% chance is there in the opposite side. That is what they mention here, right? So suppose if you are having 95% confidence, then balance 5%, so it is the negative side of our assumption, right? That is opposite to our assumption. That is what. Next, p-value. The p-value or probability value is a number calculated from the statistical test. So graphically, p-value is the area in the tail of probability distribution. So this is the p-value, right? So both sides we are having sometimes. One tail or two tails test. One tail test or one side test. It is a statistical hypothesis test in which the critical region is located only on one side or one tail. So we are having both sides we are having tails. That means, so we are indicating p-value now in the above diagram. That is called tail side. Both side we are having tails, right? So if a test is in a test, if a parameter is greater than or less than the specific value, right? So types of one tail test, there are two types. One is left tailed, another one is right tailed. It is used to test the parameter less than the null hypothesis value, right? Left tail, left side tail, right? Right side tail is, it is used to test the parameter is greater than the null hypothesis value. So if a teacher believes a new teaching method will increase the students' test score, define the null hypothesis as the new method has no effect. Scores are the same or lower, right? That means, right, alternate hypothesis is just opposite to that. The new method increases the scores. This is the right tail test because the teacher believes the new method will increase the test score, right? No effect, we have assumed that there is no effect, but teachers believes it is definitely, it will increase the score. So that is what, right? So left tail, this one is right tail, right? If you are considering the left side, then left tail. If you are considering the right side of the normal curve, that is right tail. Two tail test, it will be two sides, right? In the region will be in the both sides. It is a statistical hypothesis test in which the critical region is divided into two sides. A two tail test will test both the parameter is significantly greater than certain range, and if the parameter is significantly less than certain range. So how much it is greater than, how much it is less than. If in a testing of new teaching method, the same example, a two tail test would be assessed if the new method result in significantly higher or lower scores compared to the old method. So both will be measured in this, right? So here two-tailed, right? Both side we are having difference between one tail and two tail, right? A test of a statistical hypothesis where the alternate hypothesis is one-tailed, either right or left. Here we are having two-tailed, right? We use either less than or greater than sign for the alternate hypothesis. Here we are using not equal to, significantly equal, this significantly not equal in alternate hypothesis. And the alternate hypothesis specify a direction like more than or less than, then we use one-tailed test. If no direction, then we will use two-tailed. Critical region lies entirely on either right side or left side, because one side, right? One side, one-tailed, right? Here it will be on both sides. The entire level of significance, that is 5%, as either left side or right side, but here split into half, 2.5, 2.5. The rejection region is either from the left side or right side. Here it will be on the both side, right? It checks the relation between the variable in a single direction. It checks the relation between the variable in any direction, that is both direction, greater than, less than, on both. It is used to check the significant difference between the sample and population parameter in one direction, either more or less. More means the right-tailed, less means left-tailed. Here it used to check the significant difference between sample and population, either side, higher and lower, that is more and less, both side. Standard error, that is denoted by SE. It is a statistical measure that measures the variability of a sample statistics. It indicates how much the sample statistics is likely to vary from the true population value. Suppose true mean is 55 and we are using some samples, then we are getting 55.2 or 54.9, then the variation 0.1 or 0.2, that is the standard error, right? So example, if you want to estimate some average height of all students in a college, we take several samples of students and calculate the average height of each sample. The standard error represents the variability of these samples, means around the true average height. So that is what I am telling you. So if it is, suppose true height is 157 centimeter, for example, average height of all students. Suppose from the sample you will get 157.2 or 156.5, like that. So there is a point something difference is there, that is called the standard error of all students in the college. So 5% level of significance, 95% confidence level, right? 10% level of significance means 90%. 1% of level of significance means 99% confidence level. Thanks.